Hey guys, so in this video we're talking about the sine and cosine of complements. And the first thing we need to do is figure out what complements are. So complements are going to be two numbers or angles that add up to, and can you guess how many degrees they add up to? If they are complements, they actually add up to 90 degrees. So two numbers or two angles that add up to 90 degrees. So an example would be maybe 80 degrees and 10 degrees. Or maybe 1 degree and 89 degrees. Or maybe 75 degrees and 15 degrees. Or literally any two numbers where when you add them up, you get 90. If you remember, back at the beginning of the year, we also talked about supplementary angles, and that's when they add up to 180. But because these are complementary, we say that they are complements and they add up to 90. So what we're going to be doing is applying this, if you could have guessed, to trigonometry. That's why we're talking about sine and cosine. So why are the acute angles in a right triangle complements? So let's think about a right triangle. In a right triangle, we know that one of the angles is 90 degrees. And we don't know what the other two are. So we don't know what that one is, and we don't know what that one is. However, we do know that if we add up all three angles of a right triangle, we should get 180 degrees, because if you add up the three angles of any triangle, you should get 180 degrees. Well, if I move this 90 to the other side using algebra, I would see here that these two angles that I don't know should actually add up to the remaining 90 degrees. So therefore, the two acute angles of a right triangle are always going to add up to 90 degrees. Okay. So if I were to investigate this triangle that I have right here, the main thing that I want to talk about, especially because we're relating this to trigonometry, is the way we talk about opposite sides, adjacent sides, and the hypotenuse. So in this shape, or in this picture, the hypotenuse is Z, because it is across from the right angle. However, you wouldn't be able to just write a statement like that for the opposite side or the adjacent side, because the opposite side and the adjacent side are relative to what angle you're talking about. So if I was talking about angle A, which side is adjacent to angle A? So the side that's adjacent is going to be the side that connects the angle to the right angle. So in this case, the adjacent side is going to be Y. However, if I was up here talking about angle B, which side would be opposite from angle B? So if you were talking about angle B, this angle right here, the opposite side would actually be the same side that was adjacent to angle A. So the side that's adjacent to angle A is side Y, and then the side that's opposite from B is also Y. And you can kind of see that they flip-flop. Same thing if I were to talk about adjacent to B. So the side that's adjacent to angle B is the side that connects angle B to the right angle. So that would be X. And then opposite from A. So if this is angle A right here, and I were to go opposite from A, I would be at that same side, side X. So what that means is if I were to write an equation for, let's say, the sine of A, remember the sine is going to be opposite over hypotenuse. So opposite from A is X, and the hypotenuse of this triangle is Z. But at the same time, if I were to write an expression for the cosine of angle B, so now instead of talking about angle A, I'm talking about angle B, but instead of sine, I'm talking about cosine. So cosine is when we have the adjacent side over the hypotenuse. So now which side is adjacent to angle B? Well, that's the side that connects angle B to the right angle. So that's going to be X over the hypotenuse, which is Z. So here we can see that the sine of one angle is going to be exactly the same as the cosine of the other angle, because the only thing that switches is the numerator. When we're talking about sine, the numerator is the opposite side. But when we're talking about cosine, the numerator is the adjacent side. But by switching the angles, we actually ended up with the same side, because the side that is opposite from A, which is X, is the same side that is adjacent to B. So when this says, why are the sine and cosine of complements equal? It's because the side opposite from one acute angle is the same side that is adjacent to the other acute angle. Okay, so let's see how we're going to apply this to some problems. So in this first one, they're just asking us something pretty basic, which is to express the trig ratios as fractions in the simplest form. So when they say simplest form or simplest terms, it does mean we need to reduce when necessary or when possible. So that's what simplest means. Okay, so sine of J. So remember, sine of an angle is equal to opposite over hypotenuse. Cosine of an angle is equal to adjacent over hypotenuse. And tangent of an angle is equal to opposite over adjacent. So in this case, if they said, what is the sine of J? The sine of J is going to be the opposite side from J. So if this is angle J right here, the opposite side is 5. And then the hypotenuse, which goes in the denominator, is the side that's across from the right angle. So if I turn the right angle into a little arrow, it always points to the hypotenuse. So that's going to be 6. Then this part says, what is the cosine? Oh, sorry, and you can't reduce 5 over 6. That's as simple as it gets. So you can just leave it. The cosine of I is going to be the adjacent side compared to I over the hypotenuse. So if I look at angle I, remember the adjacent side connects that angle to the right angle. So I is here. If I connect it to the right angle, that would be here. So this is going to be my adjacent side. And then the hypotenuse doesn't change, that's 6. So here I can see that the sine of j and the cosine of j are equal. Now that doesn't mean that the actual angles j and I are equal. What it means is that the sine of j, when you take the opposite side divided by the hypotenuse, is the same as the cosine of I, which is the adjacent side divided by the hypotenuse. And we can't reduce either of these, so we can just leave them. All right, here's another example where we are going to express these ratios in simplest form. So remember, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. And these are all on the reference sheet and they're posted around the classroom, so you can always feel free to look those up. So in this case, it says the sine of S. So S is here. The sine is opposite over hypotenuse. So opposite from S is 33. And then the hypotenuse is across from the right angle, so that's 55. Now remember, this says simplest terms, so we are going to have to reduce if possible. If you guys can't tell that this is going to actually reduce because you're going to divide the top and the bottom by 11, and that's going to give you 3 over 5. You can actually use our calculator from class. I forgot, or at least I don't know where my actual calculator is, so I printed this beautiful picture of it. But you guys remember that this button right here, this ABC button, is how we reduce. So if you were going to reduce and figure out what that number is, you would press numerator, like you're going to type in the numerator. Then you're going to hit ABC. Then you're going to type in the denominator. And then you're going to hit shift, which is this button right at the top here, shift. And then you're going to hit the ABC button one more time, and that'll actually show you what your reduced fraction is. So if you do that, if you hit 33 ABC 55 and then you hit shift ABC, it'll give you 3 over 5. And for the cosine of R, cosine is adjacent over hypotenuse. So here's R. Now remember, the adjacent side connects that angle to the right angle. So connecting R to the right angle is this side right here, which is 33. And the hypotenuse doesn't change, that's still 55. And then, so we're gonna hit, shift ABC, and it's gonna show you that that's actually 3 over 5. So you can see 3 over 5 and 3 over 5 are the same. So the sine of S and the cosine of R are equal. Okay. Now sometimes they get a little more complicated and they ask you to use some algebra to solve some problems. So this one is, what we're going to do is we're going to be solving when the expressions that they give us represent the angles. Now the way that I know that these expressions represent the angles is it's right after the word cosine and there's a little degree after it. So this is an angle and this is the other angle. So basically what they're saying right here is in right triangle. So I've got a right triangle. You don't have to draw this picture every time. I'm just going to draw it to show you what we're talking about. So if it's a right triangle, we've got an angle there. And they're telling us that the cosine of 2x, so one of the angles is 2x, and then the other angle is 8x plus Because if these two, if the sine of an angle is equal to the, sorry, if the cosine of an angle is equal to the sine of the other angle, that means those two angles must represent the two acute angles in a right triangle. And so we have to figure out a way to set this up algebraically. And so if you'll remember from the beginning of the lesson, we talked about how these two acute angles here are actually complements of each other. They actually add up to 90. So we can write an equation that says that 2x plus 8x plus 5 is equal to 90. And we can solve that equation. So I'm going to add these two like terms together. I'm going to move this to the other side. And then I'm going to divide both sides by 10. And I'm going to get that x is equal to 8.5. Now this question does not ask you to solve for x. Some of the questions will, so you have to read the directions. This question says to solve for the smaller of the triangle's two angles. So what I would do, I mean, I think you can tell that this is the smaller one because you're just multiplying it by 2. But you could plug it into both of them and then the answer is going to be the one that's smaller. But 2 times 8.5 is definitely smaller than 8 times 8.5 plus 5. So the smaller angle is 2x, so it's going to be 2 times 8.5, which is going to be 17 degrees. So just make sure you're paying attention to the directions. Sometimes they'll ask you to solve for x, and sometimes they'll ask you to solve for the smaller angle. Sometimes they'll ask you to solve for the larger angle. So just pay attention. Okay, and then the last type of question is whenever you are solving, but the expressions actually represent the sine and the cosine. So they don't represent the angles, they actually represent the sine and the cosine. So remember what we learned at the very beginning is that the sine and the cosine of complements are equal to each other. So if this is the cosine of B is this value and the sine of C is this value, these two pieces are actually equal. So that's how you would set up your equation. And this question just asks you to solve for x. So I would set them equal. 5x plus 0.05 is equal to 2x plus 0.53. And then I can just solve that equation. So I would move this 2x to the other side. That zeroes out and you get 0.53 over here. I can subtract 0.05 minus 0.05. So I get 3x equals 0.48. And then divide both sides by 3. And I'm going to get that x is equal to, and I actually forgot a calculator, so I'll do this by hand. Goes in 16. So 0 point, so that's 3, subtract, that's 1, bring down the 8, 3 goes into 18 6 times. So x would be 0.16. All right, so hopefully that helps you do the Delta Math assignments on complements. And you can message me on Remind if you have any additional questions. Good luck.